I was just praying with my eyes closed that this was going to work.
Things, if they're going to go wrong, do go wrong. This thing could fail, you know.
If it doesn't work, it's over. Lights off.
Exploring the solar system is not for the faint of heart. It requires courage, determination, and ingenuity.
This is like the first Renaissance voyage over the oceans, but it's to another planet.
Can we send a spacecraft through that environment?
There's no question whatsoever that this is one of the most difficult technological jobs that the human species has ever tried.
It's a very violent, dangerous, deadly place.
But the rewards of risking everything are worth it.
Holy gosh,
I was stunned.
we found the Holy Grail.
Mars has a sense of romance about it because it's a place, it's a planet, it's another world.
79 moons, each one their own world of ice or rock.
It's definitely the most interesting place in the solar system.
Pluto is the Everest of the solar system. The farthest, and coldest, and hardest to reach.
Wouldn't that be cool if Pluto has or had life?
We're thinking, holy crap, Batman.
This series reveals how we explored our solar system,
I felt this was a more thrilling moment than Apollo 11.
told by the people who dared to do it.
When I first saw the images, I was amazed.
We had a rock from Mars, a smoking gun.
Risking reputations on missions that were decades in the planning, that could fail at any time.
NASA are taking a big risk here.
This is it. This is actually the end. It definitely led to a lot of tears.
These are the missions that changed how we see the solar system and ourselves.
We are the only generation that will ever explore the solar system for the first time.
As I take man's last step from the surface for some time to come, but we believe not too long into the future, I believe America's challenge of today has forged man's destiny of tomorrow. We leave as we came, and God willing, as we shall return, with peace and in hope for all mankind.
The exploration of our solar system really is part of the quest to understand our place in the universe. You know, without our solar system, we wouldn't exist. And, you know, why did this one little blue-green planet appear around this perfectly ordinary star? Is this a story that is repeated time and again throughout the universe?
The solar system is both vast and ancient. At least 4.5 billion years old. Now, for the first time in human history, we have images in stunning detail of all the major planets and many moons, asteroids and comets taken from space by machines of human design. From the surface of the Sun to the frozen highlands of Pluto and beyond, these images bear witness to the talents of the men and women who went in search of answers to the biggest questions. And this episode is about how and why they went looking.
The moment we discover that life developed somewhere else will be the greatest scientific discovery of all time.
sun at the centre of the solar system is an incredibly hot object. This hot, raging ball of gas. In order to be able to truly see the sun, the interior, the surface, the atmosphere, we have to go into space.
Status check. Go Delta. Go PSP. First stage systems. Propulsion. Go. Hydraulics. Go. Locks. Go.
This mission has been a long time coming. You know, for 60 years we tried to do this mission.
We're going to go to the most extreme environment in our entire solar system. We're going to go in and we're going to touch the sun.
8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the sun.
Humanity, I think, has a general quest for knowledge. We tend to just ask questions and wonder why. The nature is to look up and to look around you and to want to understand your surroundings. And so the first thing anyone looked up and wondered about was the sun.
I think it's been, over the years, seen as at sometimes friend and at other times as foe.
The sun is a constant in our lives. It rises every morning, it sets every night. And yet when you look at the sun, you will see that it is anything but constant. It is a continually changing, incredibly active star.
The story of the sun is very much the story of the solar system. Finding out how it works is still a work in progress.
That hazy atmosphere that you see during a total solar eclipse, the sun's corona, is hotter than the surface of the sun. And that really doesn't make sense. It breaks the laws of physics. You move away from a hot body, it should get colder, but something is happening in this region that really heats this material.
And we don't know why. If it's that hot, why does the gas stay on the sun? Hot materials move really fast. And if the gas molecules are traveling faster than escape velocity, there should be a wind streaming away from the sun.
And this radical idea was predicted by an American astronomer, Eugene Parker.
In 1958, space was thought to be a hard vacuum. And while the light and heat from the sun could pass through space, the enormous gravity of the sun would prevent any matter, such as gas, from reaching us. But Parker thought differently.
The idea was contradicted by several observations.
He went through the mathematics, he went through the physics, and he predicted the hot atmosphere of the sun has a high pressure, so the gas is wanting to push outwards. And there's a really important consequence of that. The gas streams out into the solar system. The sun is literally expanding into space.
I realized that we had the supersonic expansion of the outer atmosphere of the sun.
A completely radical idea. Eugene wrote up a scientific paper, submitted it to the Astrophysical Journal, and it got rejected.
Hardly anybody took it seriously. I've received several polite and not so polite declinations.
Parker asked the then editor of the Astrophysical Journal, Subrahmanyan Chandrasekhar, to look at his paper again. Chandrasekhar couldn't find any mathematical flaws in Parker's work.
The editor said to Eugene, so, do you really think there's something in the work you've done? And he said yes, and the editor published it.
But still, it's ridiculed.
Just because the paper was published had no positive effect. They were not behind it because they just believed it was wrong.
3, 2, 1, 0.
years after I made the proposal, there was a spacecraft going to Venus.
And they did indeed discover that the sun does have this outflow of gas coming from it. The solar wind does exist.
The rest is history.
This discovery was momentous. All of a sudden, space is no longer a void, it's no longer a vacuum. It's filled with material, it's filled with this wind from the sun. The speed of the solar wind, it's almost beyond belief. It's moving between 250 and 750 kilometers per second. And it has some real significant effects on our planet.
8.
In 2018, NASA launched a spacecraft called the Parker Solar Probe.
2, 1. Liftoff of the mighty Delta IV Heavy rocket.
It's the only spacecraft ever to bear the name of a living scientist.
To shed light on the mysteries of our closest star, the sun.
Wow! Go, baby, go!
The sky lights up and you realize that it's never coming back.
What a way to start.
Yeah.
Being the closest planet to the sun, Mercury is a world of extremes. But even here, explorers would find something that few expected.
When I became the head of planetary science, Messenger had launched, and it was on its way to Mercury.
Messenger was all about exploring the full surface that we'd never seen before, but also we had to really think about how we develop our technology to survive this environment. One of the main concerns for us with an orbiter is we go from one side to the other in a very short time period, a few tens of minutes. The day side of Mercury plus 450 degrees, the night side about minus 180. So the extreme in temperature is over 600 degrees swing between one side and the other.
The Messenger spacecraft went into orbit around Mercury 7 years after launch. It was designed to study the smallest of the planets using a whole suite of sensitive instruments.
What Messenger did was it provided, as its top science priority, a high-resolution image of the entire surface of Mercury. But the mystery was that there were bright spots. There were small, bright spots. And then one of the Messenger scientists took all of the bright spots and laid them down on the map of Mercury. Every single bright spot was inside of a crater that is permanently shadowed.
We have found what we believe is ice, water ice at Mercury. It's in one of the hottest regions in our solar system. So how did the ice get in there? Has it been through meteor strikes, because meteors have water? Has it been through comets hitting the body? Comets have a lot of water. It's really an enigma.
It used to be thought that Earth is the cradle for life, therefore all organic chemistry in the solar system is probably concentrated in the band that the Earth's orbit maps out around the sun. But we're now studying the water cycle, literally throughout the solar system. So when you're talking about where life is and where the kind of chemistry and ultimately biology that might produce something like us could take place, at the moment it's looking like it might be broader than just one little planet at the Goldilocks distance.
The
Soviet Union, they understood the huge propaganda value of victories in space. The best way to prove superiority would be to get to Venus first.
We should not forget that every launch is also perfecting essentially military technology. This was the giant military missile development program.
Space exploration has a dark side. We can't deny that we rode to the moon and to the other planets on, on the wings of war. The reason we have these rockets that can launch payloads into orbit and beyond is because they were developed to destroy cities.
The Cold War made possible ever more ambitious missions in the 60s and 70s, each a matter of national pride. None more so than Venera 9. This huge, complex spacecraft was built to enable Russia to be the first nation to send back an image from the surface of another planet, Venus.
On 20th of October of 1975, this joint stack of spacecraft of lander and orbiter approached Venus and separated from each other. Immediately, they started their separate missions, which were culminating at the same time. The orbiter approached Venus and started a braking maneuver with its engines to slow down its speed just enough that the gravity field of Venus would capture it and leave it into a highly stretched elliptical orbit around the planet.
This component of the Venera 9 spacecraft had become the first man-made object to enter orbit around Venus. But the mission was far from over.
And at the same time, the lander started going into the atmosphere of Venus on the side of the planet which was not visible from Earth. But thanks to the orbiter, which was so high in the sky over Venus, it would later act as a relay station for the lander to send pictures back to mission control on Earth. The lander was a ball-shaped capsule covered with a special ablative surface. And once it entered the atmosphere of Venus and started braking, layer by layer burning the ablative surface and at the same time slowing down tremendously from its initial entry speed.
The searing heat shield decelerated the lander from 10.7 kilometers per second to around 250 meters per second.
Then, once it slowed down enough, it was safe enough to open small opening at the top of the capsule and release two small braking parachutes. One of those two parachutes was then used to release the top part of the capsule and reveal the top of the lander, which was inside of that cocoon.
The speed dropped from 250 meters per second to 150 meters per second before a third parachute was deployed.
And once that happened, there was an antenna, a transmission antenna exposed, and that allowed it immediately start transmitting data to the orbiter, which in turn relayed back to the ground control.
The third parachute brought the velocity of the lander down to just 50 meters per second.
And then that parachute was separated, and it pulls out three-canopy main parachute system, which allows the lander really slow and gentle descent.
After all the drama of its journey so far, the lander would then spend 20 minutes calmly taking measurements of the atmosphere. But its brutal voyage was not over yet.
When the probe is around 50 kilometers over the surface, the command is sent to cut the main lines of the parachute.
And then you keep falling, and the atmosphere gets hotter and hotter and more dense, to the point where it's 100 times as dense as the atmosphere on Earth. And that means that you're falling through, it's not quite a liquid, but it's a gas that is approaching the properties of a liquid, and that would slow your fall. And then when you get to the surface, it's almost like going through the ocean.
Venera 9 wasn't the first lander to get to the surface of Venus, but it was the first to send back pictures. Finally, this image, the first image ever seen by humans of the surface of another planet, came back.
Everybody, without any question, who was involved were understanding the historic and scientific significance of that achievement.
That was a real triumph of exploration.
These rovers were not inanimate objects to us. We were part of them and they were part of us.
The exploration of Mars has long been a top priority. In 2004, 2 rovers, Spirit and Opportunity, landed on the Red Planet. For the people who sent them there, it would prove to be an emotional experience.
Gusev Crater has a drainage channel that extends for thousands of kilometers through the ancient highlands and looks like it filled that crater up with a lake. This was a location where sedimentary rocks that could tell us about the environment when it was active would be. We got images pretty quickly.
Unfortunately, we got there and all we could see basically was volcanic stuff.
Gusev was basically a basaltic plain, which is lava flow.
So if the lake had ever been there, it had been covered by volcanic materials.
We were crestfallen that none of our predictions about what materials would be there were that we were wrong. The Opportunity was completely different.
Opportunity really hit the bullseye because it landed in a place called Eagle Crater, in which Mother Nature has done you a big favor. At some point, she slammed a meteorite into the surface of the planet, excavating this big hole, and basically gave you this archaeological dig, if you will. You land in the middle of it, and all you gotta do is look around, and here's the history of Mars.
And we saw sedimentary rocks.
When geologists go out in the field here on Earth, they want to look for layers of sediment that have accumulated over time. This is literally the historical pages of the book of the Earth. At this level was where the dinosaurs were, and at this level they died, and at this level new life became. You can just read that book of history.
There was this treasure trove of information that just kind of flooding back. These were not igneous rocks. These were sedimentary rocks that would have been formed by liquid water. And it was a classic sedimentary sequence that we've seen on the Earth in many places.
And this is where it really gets interesting.
We see these little bead-like things in the soil. We thought, what could these be? I mean, people started conjecturing. But when we put the infrared eyes on them, we can see iron and oxygen in them. We're thinking, holy crap, Batman. We found hematite.
Hematite is a mineral here on Earth that's formed in water, and a lot of it, in moving water, that allows this mineral to be formed. And they were all over the place.
Holy gosh. We found the Holy Grail. So the whole point of the Mars exploration rovers was roving. We want to move.
The rovers were expected to last just 90 days. But as both of them explored the Martian surface, they proved they could go for much longer.
They outdid their warranty by factors of hundreds.
We're several years into the mission that we had real trouble with Spirit. Spirit had lost one drive wheel. In doing so, we got stuck in a sandy crater, and it was very difficult. And that was the end of Spirit, yeah.
But Opportunity just shines like a radiant star, because this rover keeps going and going and going.
Opportunity really began to show evidence of past water.
We started to see the kind of mineral signatures that were the stuff of dreams, that support water as a persistent liquid phase.
Water that forms the Burns Formation.
Deposited by water.
River flows, groundwaters.
If you were there when the water was there, you could drink it.
This is just this ongoing saga of water. Water everywhere.
Then in 2012, a new rover drops into the party. Curiosity, equipped with a drill and carrying an entire laboratory on its back. This machine rolled into town and immediately changed our view of the Red Planet.
As we dug into the soils, and we found, to our delight, it had carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. That's everything between these two fingers. All the right stuff that life is made of is on Mars.
Meanwhile, after 15 years on the surface, Opportunity had covered a record-breaking 45 kilometers, documenting every step of the way.
It's this unstoppable machine. It just keeps driving. And then in June of 2018, here's a dust storm in the distance. It turns out to be a whopper.
The sun was almost blacked out. And at that point, there was no power getting to the panels, and we tried for months and months and months until there was just nothing. And at that point, you eventually, you say that's the end, yeah.
We had one final day where they called the team out to JPL, the Jet Propulsion Laboratory, where anybody that wanted to come and be there when they sent the final commands could come. We had all gathered in this area called the Dark Room, overlooking mission operations, and we're watching the flight commanders sending off the last commands to the rover. We did basically 4 final pings. The light time delay comes and goes. We got no signal, and everybody just kind of sits there in silence. And then the manager of the mission, John Callis.
This concludes operations for MER-1, spacecraft ID 253.
Says, thank you for your 15 years of service.
Thank you.
But this is the end, so this is MER signing off the net.
MER project off the net.
In the dark room, it was just silent, and everybody's kind of looking around, and we're like, this is it. This is actually the end. It definitely led to a lot of tears.
We were there. We are there. Our consciousness is there. Our species consciousness is on Mars. We're already a multi-planet species.
Comets are the leftover rubble of the solar system. They never quite made it into planets. But they preserved the material that are the building blocks of everything we can touch, feel, taste, smell, or see today.
To learn more, you want to go and rendezvous with a comet. You want to fly alongside it. And of course, then the idea comes up, you would want to touch down on the surface. You want to land there, sample material.
To do all of that in one mission is incredibly gutsy.
The first time I heard about the mission, I thought they must be joking.
The Rosetta mission was incredibly ambitious, but we jumped on it.
We launched in March 2004. The whole travel to the comet was an adventure for Rosetta. The comet is on an orbit with a different energy level compared to the one of the Earth, so we had to actually impart this energy to our spacecraft to get to the same orbit.
So we did this thing to use the planets and to use their gravity to slingshot us through space on a different trajectory with more speed in order to be able to get to the comet.
After this, we came back to Earth. This one gave us the last big kick. We were really launched very fast, but getting very far from the sun. We could not keep all the systems on board active because the illumination of our solar panels was getting very weak.
So the decision was made, in fact, to turn it off.
I hated that concept from the very beginning. I've been fighting it for years. I was convinced we would never do it. It was too crazy. Switching off the radio signal is like cutting a vital link.
You've been flying a spacecraft for 7 years. It's at hundreds of millions of kilometers away. And what do? You send a command to switch it off and wake it up 3 years later. It just doesn't make sense. And this is what we did.
We spent 2.5 years without contact. And we waited.
We couldn't talk to it while it was in hibernation. We needed it to wake up, which it was due to do on the 20th of January, 2014.
Wake up! Okay, great. We were sitting all in the control room, waiting for the signal to come. And this was probably the most tense moment of the mission. This was everything or nothing. It was life or death.
Why is not coming?
Everybody was getting very nervous.
It was very difficult to bear. We started really getting worried.
Have we lost the mission? Then suddenly, the signal came.
When the signal came, it was a big relief for me personally. There was an explosion of joy.
A little blip on a noise spectrum told us Rosetta was there and it was calling home. And this for me was the the toughest emotion I went through on the story of Rosetta. We made it. Yes. That's a big success for everybody.
We have it. We're ready. We now have the spacecraft back. We can go and do the rest of this mission and finally get to the comet.
But now the mission starts, because now we have to get to the comet, fly around the comet, orbit the comet, and land on the comet, all within the next 10 months.
Rosetta took 10 years from launch till we finally got to the target that we were going to study.
The comet we ended up deciding to go to with 67P Churyumov-Gerasimenko.
At the beginning, the comet was just a very small dot. And then day by day, the comet was growing in the field of view of the camera.
You have this spacecraft visiting an ambassador from the solar system from 4.5 billion years ago. It's modern technology visiting an ancient relic. It's really profoundly emotional.
We saw this incredible shape. Some people have described it as a rubber duck.
It was amazing. It was beautiful. Scientists were just stunned with their mouths open. Comet 67P is about 4 kilometers in size. If you were standing on the bottom of the comet, you might see a flat, dusty plain. If you were standing on the head of the comet, it might look more rocky. If you were standing on the neck of the comet, you would be in this interesting valley, kilometer-high cliffs on either side, and running along the neck between your legs is a huge crack. There's so many different types of surfaces and variety. You could spend the rest of your life exploring every little part of the comet and not see the same type of thing twice.
Jupiter, the largest and most intimidating of the planets, is certainly one of the most beautiful and intriguing. In 1995, a spacecraft named Galileo arrived and soon got to work.
The Galileo spacecraft carried along with it a probe, and it's sort of like this size, and it had a big heat shield to protect it around it. And so in July 1995, we launched that probe and sent it in the direction of Jupiter. Now, it didn't have engines, so we weren't guiding it and saying, go there. We just sort of sent it on a trajectory towards Jupiter.
5 months later, on the 7th of December 1995, the Galileo probe was due to arrive at Jupiter. There were no cameras on board, only sensors and a little probe that was going to have an extremely violent introduction to Jupiter.
It was coming in at something like 130,000 miles an hour. So it was pulled in by the gravity of Jupiter, and we had to slow it down. And so this heat shield heated up to about 3 times the temperature of the surface of the sun. And then eventually we kicked off that heat shield, put up some parachutes, And so as it went down, we were able to get a sense of what it was like. What we were expecting was 3 separate layers of clouds. And we went down and said, where are the clouds? Where are the clouds? We're not seeing the clouds. What's going on? So everybody was completely confused. Well, the hint came from the ground. Telescopes on Earth were looking in the infrared at Jupiter at the same time we sent the probe in. And we realized that the probe went into a hot spot, somewhere where there's very little water.
And so I think we realized that our whole idea of exploring these planets with single probes is a little bit susceptible to going into the wrong place.
By the time the probe had got down to about 160 kilometers, something like 23 times atmospheric pressure, it was now starting to get really hot. And so at that point, the electronics is just not working anymore, and it stops communicating and sending signals back to the Earth. What happened to it after that? Well, it was so hot that it basically vaporized. But let's imagine what it would be like if you could be in a pressurized capsule as you get deeper down.
I mean, it's either a hang glider's nightmare or his dream, depending on how risky they want to be.
As you went deeper and deeper, it would get a little calmer, a little less turbulent. The pressure would get higher and higher.
It's so hot, everything's vaporous. Eventually I get down to material that are almost like rock clouds, and they're probably precipitating.
Now, when you get down something like 10% of the radius, you're now getting to the point where the pressures are about 1,000,000 times Earth atmospheric pressure. And the density is getting really high. And at that point, hydrogen changes its phase. It's no longer molecules, protons and electrons connected together, but the protons and the electrons are moving separately, and it becomes metallic. That is, it becomes electrically conducting. I suspect it would look like mercury. A glob of mercury is what it would probably look like.
If you existed, you would be, unbelievably thin, flat-out pancake.
You get to the center of Jupiter, we're talking 4 times the temperature of the surface of the sun, 50 million atmospheres pressure, and a density that's denser than the heaviest metals that we have on Earth.
Seconds and counting. This is Titan Launch Control.
Without any doubt, the most risky element of any space mission is the launch.
T-minus 15 seconds.
When you've put 8 years of your life into designing and building and testing something which is going to go into space,
9, 8,
and then seeing it on the top of a rocket that's being vibrated and accelerated on its way to Saturn, it is quite a feeling.
1.
When it did go off, it created a huge amount of light, and then the rocket went behind a cloud.
When it went behind that cloud, it was very impressive. The whole cloud lit up.
We all thought, oh goodness, has something gone wrong?
And then the nose cone came out and you went, whew.
Exploring a planet such as Saturn is a very risky business. This mission, called Cassini-Huygens, was one of the most technically demanding ever undertaken.
When Cassini was approaching Saturn for the first time, our experiment was systematically scanning back and forth the planet Saturn. And we were amazed to discover that the system was filled with molecules of oxygen. And we mapped this out, and we noticed that the peak in the distribution was just a distance 4 times Saturn's radius from the center of the system. We knew that the moon Enceladus was orbiting just at that distance.
Enceladus is a tiny moon, just 500 kilometers in diameter.
Enceladus originally was on the itinerary,
but only marginally so. It was another very interesting Saturn moon. Small, very shiny, very white, very bright. But other than that, too small to be interesting.
It was in the first close flyby that the magnetometer team detected something interesting that they didn't expect.
It looks like it has an atmosphere. Well, anybody that knows anything about moons says that's too tiny. It can't have an atmosphere. It's way too small to hold onto anything.
If you flew by the South Pole, it looked like there was an atmosphere, but if you flew by at the equator, you didn't see anything at all.
But then we went back again and again, and all of a sudden realized that not only it had an atmosphere, it was an icy atmosphere, but it had these plumes coming out of the southern pole.
And here's water geysers, you know, on a tiny moon.
And that water that was coming out of what we've later found out to be an interior ocean, not only did it contain water vapor, but it had traces of ammonia, methane, H2, CO2, and then there was a whole host of organic compounds that we could also see.
And now we can put all that information together to get a picture of the shape of the eruption and also the material that's being erupted from inside of Enceladus. And amazingly enough, that material has the basic building blocks of life. This says to me that would be a good place to go and see if there's any form of life there.
Far out near the edge of the solar system lies a world that, until recently, was completely unexplored: Pluto.
As we were flying up to Pluto and imaging it day after day and week after week on approach, we could see this bright feature on the surface. One morning, we got an image back, and as soon as it came up on the big screen, I remember a NASA official who said, "Do you see that? Looks like a heart." And as we got closer and closer, amazingly, it looked more and more like a heart. I think that's what emblazoned Pluto into the public mind as this amazing place at the frontier of our solar system.
Pluto's heart measures 1,600 kilometers across and is composed of nitrogen ice.
We believe that structure might be supported by water underneath the surface. There could be an ocean underneath Pluto's surface.
There probably is some kind of liquid water ocean. It's very deep down inside, but we think there's a pretty good chance that it's there.
It's one of those things where if you find water, is there a chance for life? Wouldn't that be cool if Pluto's actually one of those places in the solar system that has or had life? That's just mind-blowing right there.
The exploration of our solar system is far from over, but it has already taught us what a rich, varied, and strange place it is. But perhaps the biggest realization is just how special and precious our home planet is.